good afternoon to one and all. I am Ram Bansal, Assistant Professor, Department of Mechanical Engineering, Medical University, Indore, India. Welcomes you all on behalf of organizing partners of this FDP, Medical University, Walos University, Galgotia University, and Satyabama University, in third day of International Faculty Development Program on trends in automotive technology. Our eminent speaker of today's second session, Mr. Hagos Abe Tefe, has joined us. Uh, Mr. Hagos is a lecturer in Department of Mechanical Engineering, Motor Vehicle Stream in Volvo University, Ethiopia. He will enlighten us on the topic of braking system of automobile. Uh, so I welcome, sir. I welcome to you, sir. Now
welcome, sir.
Now session is over to you, sir.
Okay, thank you. Thank you for giving this opportunity, sir. I am glad to have attend this an extraordinary event. This is first time that I attend with the international events. So my topic is automatic brake system. There are some contents that I am going to present in this presentation. Here there are some introductory parts, factors governing braking, and also some brake lining materials and types of brake systems we will see in this session in detail. So as an introduction, it is obvious that and commonly believed that the purpose of brake system is to slow down or to halt the motion of a vehicle. This is the principal thing for brake system, where in principle, the friction against the road will make it stop the vehicle against motion. That means the brake will slow and stop the rotation of the wheels. There are static friction and dynamic friction or kinetic friction which are available in the vehicle. When you say static friction, the friction between the road and the wheel, and kinetic friction is a friction between the moving parts when we apply a brake by might be mechanically or hydraulically. The contact between the pads and the pad and the rotor will create a kinetic friction. So this is what makes the vehicle to stop during braking action. There are some factors which govern braking. One is pressure, which is coming from the hydraulic system. The other is coefficient of friction. This will represent the frictional relationship between the pads and rotor, or it might be from shoe and drums. The other is frictional contact surfaces. When we say frictional contact surface, the bigger brakes more have high brake than smaller brakes. And the other thing is heat dissipation. So when you say heat dissipation, during braking system, there is high heat dissipation during between the pads and the discs. So this will prevent from brake fade by selecting the proper and required brake lining materials. So when you say brake lining friction materials, they are made up of relatively soft and high heat resistance with high coefficient of friction, and the lining is attached with a metal back, and which is attached by rivet or high temperature adhesives. In old trends, the brake lining was asbestos, but this asbestos have its own disadvantage. It's toxic and hazardous. Due to that thing, researchers nowadays are trying to neglect this kind of brake lining material, and they are using nowadays fully metallic, semi-metallic, and non-asbestos and synthetic as well as ceramic materials they are using nowadays. So type of brakes, there are different kinds of brakes which are available for the vehicle. One is hydraulic brake, the other is mechanical brakes, which is maybe found mostly in vehicles, kind of handbrake, or it might be in emergency brake, which is mechanically linked, and the other is drum brakes. This mechanical linkage may be found in drum brake or disc brakes, and other power brakes are available for modern vehicles like air brakes. Example, heavy trucks and buses are using this kind of air brakes. The other is vacuum assisted brakes, electric brakes, electromagnetic brakes. These electromagnetic brakes are found in modern vehicles and hybrid vehicles. So when you say the hydraulic brake system, this is done by the hydraulic fluid. So this fluid is some glycol ether or diethyl ether, which pushes the force and transfer to the wheels. So in this, the force will be generated by the brake pedal initially, and then it will multiply by a booster, and then the booster will give force to each front and rear wheels. So this is the overall schematic drawing of hydraulic brake system. So starting from the master cylinder. So when a driver is applying brake pedal, so initial force is given to the master cylinder. Then the master cylinder, by applying brake boosters, so that means in vacuum assisted boosters, or there is an initial of air which comes or integrated from the engine, whether it is driven by the engine or by pump. So it gets some vacuum creation between the diaphragm in the booster. So this vacuum creation will create high force generation in order to send the force and multiply to each wheels by respective valves. So once it is coming from the master cylinder, so this master cylinder is kind of dual type and dual type, or so-called tandem type of master cylinder. So this is combined with metering valve and proportioning valve. So this will be given for the front wheel and rear wheels. That means for the disc and for the drum brakes respectively. So when I say combination valve, this is recently integrated in newer cars with hydraulic system, and this combines the metering and proportioning valve with differential pressure differential valves. So when you say metering valve will differentiate the hydraulic pressure to the equalize the front or disc brakes, whereas proportioning valve will allow the system for the drum brakes. The other thing is power brake. So this power brake is so-called brake booster or brake servo. When the driver is giving a brake pedal or depressed a brake pedal, so force is generated. That means atmospheric air will be initially enter this, and the push rod will push this spring, and there is a vacuum which comes from by the engine. So there is pressure difference occurring inside the booster. So that pressure difference will expand this diaphragm and let it the hydraulic system will allow to the master cylinder by multiplying the given pedal force in order to achieve high braking efficient to the required disc brakes and drum brakes. So this is the system, what I explained already. So in mechanical brakes, so this is mostly found in handbrake and emergency brakes. So this is mostly found in disc brakes and drum brakes. So this will be applied on the brake pedal and carried out by the drum or disc rotors. So mechanical brakes are found in several old automobiles nowadays, and this is archaic nowadays due to their less ineffective. But in recent days, these disc brakes are used in motorsports like racing cars with ventilated disc rotor for the case of ventilation system or cooling systems. So basically, in drum brakes, there are mechanical linkage for in case of hand brakes and hydraulic, which pushes the wheel cylinder in order to contact the between the lining and the drum. So actually, this will be making a contact between this lining, brake lining, and the drum drawing, giving a braking system by the hydraulic. So when the friction lining and this drum makes contact, the rotation of the wheel will be halted. So at that time, so the brake will be engaged. In case of disc brake, so the fluid from the master cylinder is coming to this wheel cylinders into the caliper, then it's pressed against the piston, so that the piston will squeeze two brake pads against the rotor and forcing it to slow or stop down the motion of the vehicle. And air brake systems, so in air brake systems, we need air brake system due to large commercial vehicles, its size and the force in order to get the required braking in commercial vehicles. So since the load and the size of the vehicle, as you can see here from the picture, is vary, and it's much greater, it needs high amount of force. So to achieve that, we need air brake systems in order to achieve to the it can travel with high distances due to the length of the vehicle. But if you see in hydraulic system, it's enough due to its construction and its dimension. Hydraulic brakes are enough for light vehicles. So air brakes are maybe classed in single or dual circuit brake system according to their construction. So because of their poor safety characteristics, single circuit brake systems are no longer installed in commercial vehicles, because if some failure is happening, so it will have some damage. So no longer this single circuit is used. Nowadays, dual circuit is applicable in so many vehicles, commercial vehicles and buses. So dual circuit brake systems are prescribed by law and subject to European standard. So this is so-called EC or EU brake systems, which are going to use nowadays. So as I told you, single circuit brake system, in case if some failure is occurring, so it doesn't have any backup system. So this system is no longer usable, and dual circuit is used nowadays, since if one system is failed, we can use brake system by the secondary brake systems. So this looks like the overall circuit of air brake system, which is found nowadays in so many modern vehicles. So when we start the air brake system, so the device which we capture the air is a compressor. So the compressor will compress the air which is coming from the atmospheric air by suction. Then it compresses and give to the pressure tanker. So to tanker, so there are, depending on the type of vehicle, it might be 4 tankers will air tankers will get, or 3 tankers, depending on the size of the vehicle. So the compressor is compressing. Since this compressor is driven by the engine, it might be by gear or by belt, according to the construction of the vehicle. So when the engine is running, directly the compressor also working, it's compressing air and give to the air tankers. So before entering the air tankers, you see number 5, it needs some air dryer. This air dryer will dry some moisture content of the air before entering to the compressed tank. So, and also there is another device which is attached between the tankers, that is so-called four-way circuit, four-way valve or four-way circuit protection valve. So this valve is used for 4 different brake circuit applications. So depending on the number of tankers, one may be for the front, the other is for intermediate, and the third one will be for the trailer system. So this is what we call four-way protection valve. So once the air is captured into the air tanker until it's get fully charged by the compressor. So which is almost, it arrives 8.5 to 11 something bar, 11 bar, it will charge. Then once it is fully charged, the governor will allow to make off the compressor in order not to pass to the tankers. So system or pressure is already ready in the tankers. Now we are going to use this pressure in braking system for foot brake valve, for hand brake valve, and for the trailer also. So when the driver is applying a brake pedal by the service brake, that is number 6, it gives the force for the front and intermediate, as well as for the trailer. So this will allow by relay valve. So this relay valve will give quick response of pressure to deliver at instant time for the braking action. Most commercial vehicles they are using foot brake in the front, and foot brake and hand brake and intermediate, and also foot brake and hand brake in the rear. But nowadays most heavy vehicles like Volvo truck, see, they are using hand brake and foot brake integratively, using the combined brake chamber in the front and the intermediates. So this is the system, how it arrives the brake by air brake system to front to heel and to the rear wheels. So once the brake in the air brake system is arrived to the brake chamber, so here there is pneumatic force. So this pneumatic force has to be changed into a mechanical part. Just this mechanical part is kind of S-cam. They are using mostly S-cam type. So this S-cam type will push the push rod and actuate the cams. And when the cam are actuating, so the lining and the drum will engage, and friction rotation of the wheel will be halted. So this is the principle that they are going to use. The other thing is, for most vehicles they are using load sensing valve for rear vehicles. That means for rear wheel. So according to the type of load, they distribute the pressure required for braking action. So there are some basic principles: energy supply, control system, transmission, and brakes. So when I say energy supply, by using compressors, all the things by using pneumatic, hydraulic, mechanical, even if the driver effort force are some energy supplies with their control systems. And brake systems, there are some service brakes, secondary braking system, and including the power of muscle power by the driver with parking brakes. So the basic components are compressor, that is to pump the air, with governor to control the air. The other is reservoir tank, or storage compressed air tank, and foot valve. This foot valve is to regulate the flow of compressed air from the reservoir when needed for braking, and brake chambers with adjustable slack adjusters to transfer the force to the mechanical linkage and brake linings are the air brake systems. So highlightly, the compressor is just the same principle as the engine working. So this compressor will compress the air, and during compression only it will compress the air, and it will send to the compressed air reservoirs. So once it is fully, that means when the pressure is arrived almost 8.5 bar, so the governor will allow to shut off from compressing and allowing to give for the compressed air reservoirs. The other is service brake valve. So this service brake valve is since system of air is having in the compressed air already by compressing from the compressor, then in case of operating for the brake system, the operator is giving a depress or a pedal. This valve is receiving the required amount of pressure from each compressed tankers. So as you can see here, this is upper part and lower part are synced by showing indicator numbers 11, 21, and 11. So this 11 is for foot brake valve. So maybe foot brake valve is mostly used for front vehicles, and 12 and 22 and 12 are there. This is for the case of hand brake valve. So here each will have exhaust inlet and exhaust ports. So the system which needs the air brake system specifically for hand brake and foot brake will be giving from this service brake valve, which is so-called commando valve, ordinary naming they are using. So by using this, it will allow the specific type of brake for the required wheels. That might be front brake, intermediate, and rear brakes. So here, as you can see here, the driver is allowing this brake pedal, and when pressed this brake pedal, it compresses this springs, and it allows the air which is coming from the compressed tank, and by each system, it will enter to this system and will go to the front, and the other is from rear air tanker. It will enter, and based on the time of usage, it will go out by these rear valves. So if we need brake system for rear, so the system of tank which is used for rear vehicles will enter to this brake valve, and it will go to the relay valve. So this relay valve will give some quick response during braking action. So this is sometimes so-called quick release valve. This quick release valve is mostly usable for hand brakes, whereas relay valve they are using in foot brakes. When we see the modern vehicles like Volvo nowadays, we are using this kind of systems. So when we see this relay valve, so there is some signal which is coming from the driver. That means air is coming. So the supply air also come from the reservoir tank. So once the driver is pushed, then the plunger will push the upper part of this relay valve, the upper part, and once this is pushed downward, this spring will be open. So once it is open, the system from the reservoir will be entered to the system and will let it go for the delivery of the brake chambers. So in during braking action, it will hold the brake system when the driver lets to hold the brake. The other is other parts are brake chambers and wheel brakes. So these brake chambers are some mechanical parts. That means they will convert the pneumatic power to the mechanical linkages. As you can see here there is a push rod which is coming from the brake chamber. So this is the slack adjuster. So when the air is entered to the brake chamber, so this brake chamber, based on the specific task of air brake, it might be for the foot brake, then this will push this side and the slack adjuster will also push this S-cam. So this S-cam will move up to the discus. Then the disc, there is a contact between the lining and the drum. At that time, the braking action will be takes place. That means there is no motion between the disc and the rotor. This is so-called braking action for commercial vehicles. So they are using mostly S-cam type. So the other is electromagnetic braking system. So this kind of brake system is found in modern vehicles and hybrid vehicles, just like trams and trains. They are using this type. Unlike other braking system, this kind of braking system is quite fast and it is cheap also. And also its principle is in the case of like electromagnetic action without frictionless, because the contact or there is no direct contact between the moving particles. So this will increase the life of the vehicle with greater reliability. And also there are some advantages by using this electromagnetic braking system. So its advantage is fast and cheap, and also there is no maintenance cost. We don't pay for replacing some components for these electromagnetic braking systems. Nowadays they are using magnetic braking system also. That is recent in modern vehicles. The other is anti-lock braking system. As the name indicates, it is anti-lock braking system. This was developed to assist the driver braking action by preventing the tire from sliding and keep them rotating slowly to allow steering. And this system have a safety system that allows on a motor vehicle to maintain tractive contact with the road surface according to the driver inputs while braking. And this prevents the wheel from locking up and avoid uncontrolled skidding during emergency braking system. So generally this will improve the vehicle control and decreases with stopping distance. So as you can see from the picture, the vehicle with having ABS system and not having ABS system is, when we say braking system in ABS, only applying brake is not enough. So we have to use the steering system integratively to avoid some sudden. So from to decrease some accident, will apply directly at the same time steering system and as well as braking system. So this steering system is just acting as a braking system. So at that time when the wheel is steered, it will allow to some angle deflection. So if the front and the rear vehicle angle of the wheel is not balanced, that means if the translational velocity and rotational velocity are not equivalent, there is imbalanced. So if there is imbalanced, the vehicle have a high tendency of what you call skidding, and also there is yaw rate movement rotation during emergency brake system. So the other advantage is it enhanced braking action, and also it enhanced the vehicle stability and stopping distance. So as you can see from this picture, only braking is not enough for the to avoid collision during accident. So just like a steering system is also acting as a braking system. So there are some components which are integratively used in this ABS system nowadays. The first one is ECU. The other is ECU, which this ECU receives signal from sensors in circuit and controls the brake pressure at the road wheels according to the data which is analyzed. So this assists the vehicle operator to prevent wheel lockup by regulating the wheel slip. So the vehicle which have higher grip will prevent wheel lockup by using this pressure differentiating to the rear vehicles by using distributing mechanism. The other is hydraulic control unit or modulator. So this will receive signal from ECU to apply or release the brake under ABS conditions. So in case of if the vehicle is in wheel lockup, so the ECU will send a signal to this hydraulic control module. So this hydraulic control module will block the system for the master cylinder, so that the ECU will send a pressure in order to have velocity, that means velocity and high ground or contact pressure. That means it will increase the grip between the surface and the wheel, so that the vehicle will come up or allow from locking. The other is for booster. This will be activated by the driver in the brake pedal, and sometimes they are integrated between the master cylinder and so the other system is there are electronic brake distribution during braking action in ABS systems. So this will, as I told you, a vehicle which is having during emergency braking system, if we apply, so there will be a yaw rate of the vehicle, which increases the slip. So if the slip is increasing, so there is an uncontrolled
Sir, you are muted.
Sir, now it's audible. Sir, is it audible now?
No, sir.
Sir, 1 minute, sir, 1 minute. Sir, now is it again share the screen?
not shared. Mm.
Now,
Oh.
sir, now screen is visible, sir?
Yes, sir. Slide is visible.
Okay. Okay. Thank you. Sorry for disturbance. Some electronic braking distributions are integrated in the ABS system. So suddenly, when we apply the brake system or emergency brake system, so there is an imbalance of uncontrolled movement of the vehicle. That means it increases the slip. So this slip is mostly increasing of between the road and the wheel. So to avoid this, by reducing the brake pressure on the wheels by modulating with a higher grip, it can be able to reduce the frictional force to produce in these wheels, so that the vehicle will come to some steerability and in normal positions. So it will reduce the yaw rate of the yaw rate system of the car. That means the transitional velocity and rotational velocity of the vehicle has to be 0 for each wheels. So this is the continuation of the diagram which shows for the ABS system. When the driver is push the brake pedal, it gives the some fluid to the by the power booster and master cylinder assembly, and it goes to the hydraulic control unit or the hydraulic modulator. So this by calculating the type of the and the required amount of system, it will go to the wheel. So in the wheel there is wheel speed sensor. So according to the rotation of the wheel, it gives the required pressure in order to activate the braking system for specified wheels. So in this system, there are 1 channel, 3 channel, and 4 channel systems in ABS system. when you say what?
Agus, please on your video, Agus. Your video.
Okay. Now, when I say 3 channel, there are three channel systems, 3 control solenoid valves with control brake pressures. So one channel is used commonly for rear wheel anti-lock system with ECU, and 3 channel, as I told you, which is used for rear wheel together and front independently. And they are using 3 speed sensors and 1 control module. So this is a little bit a brake system nowadays, from old to modern vehicles that I am that I have already presented. Thank you. I have finished my session.
Thank you, sir. Thank you very much for your presentation. Nice presentation. Participants, if you have any query, then you can ask your question. You can write your question in chat box, as well as you can raise your hand. Okay, I think there is no any questions. So thank you, sir. You have very well explained about the different types of braking systems, their construction and working, and we know the vehicle can't propel without braking. We can't stop the vehicle without braking. So brakes are very important for the vehicles. So it is a very important part or component of the vehicles as well. So you have very nicely explained the different types of brakes and their constructions. Thank you so much, sir. Thank you for sharing your knowledge with us.
Thank you. Thank you, sir.
Okay, sir. So now we are going to end this session today. Today's session. We will meet again at 11:30 a.m. tomorrow. Have a nice day to all of you. Thank you, everyone. Thank you to join us. Have a good day.
Okay, thank you.
Stay safe, stay healthy. Thank you. Thank you very much.